Hi, thanks for watching. Today we'll talk about CDN cache to drastically decrease page load times without sacrificing data consistency. After a brief introduction, we'll talk about our overall architecture. Then I'll dive into cache, and more specifically, stale-while-revalidate cache. My name is Lauro Arujo. I'm a senior software developer at My Planet, where I've been working for 2.5 years, mostly doing JavaScript full stack development. But I'm mostly focused on the front end nowadays. My Planet is a Toronto-based software studio building digital experiences in commerce and other areas. We build for web, apps, voice, and other interfaces. Today we'll talk about some important decisions we made while building a headless experience for retail commerce in a big retail Canadian store. With a shift towards headless content in commerce, front-end developers have their peak of technology. There are many ways to approach headless optimization. Front-end devs and architects are looking always to deliver a fast experience, and Next.js is really a good choice. But sometimes it's harder to convey that for the business side. And I hope that after this presentation, you'll have some more arguments to give the business people and explain what are the benefits of headless commerce. So this is just a basic overview of our architecture. We have headless CMSs and commerce platforms, and we have other systems, but these are the two that we interact the most. We have a Next.js frontend served in Vercel, and we use server-side rendering. If you're familiar with Next.js, we use get server-side props because we use serverless functions to generate our pages and also for our APIs. Both these serverless functions, the one that generate the page and the API ones, can leverage stale-while-revalidate cache, which will give us a big boost in performance, making things look like you're serving static content. As you can see here, whenever a user makes a request, our pages and some of our API responses will be cached on the CDN, making it really, really fast. However, regular cache is not always that useful if you have dynamic data. But stale-while-revalidate ensures that your data remains fresh and your cache is always up to date. We'll talk about that in a moment. So before we dig deep into stale-while-revalidate, I just want to touch a little bit on the types of cache we have, or the places where cache can happen. So usually when you're having cache issues, we usually try to ask users to refresh the cache on the browser. And usually this has to do with the browser cache, which is governed by the max age header. This cache is not something that we basically use. Next.js basically manages it wherever it doesn't make sense to cache, it won't cache. If it makes sense to cache because we have like unique names for every resources, it will do that for you. So that's not the main point here. Another place we can cache information is on data fetching libraries. So these libraries usually will save your request in memory or in any other storage in your browser, and we can leverage it to make this experience a little bit better. We will use it, but that's not the main point of this presentation, and it is not the main technology we use. We cache our pages on the CDN level using the stale-while-revalidate header, and I'll talk a little bit more about what that means and what are the benefits of it. So with this new header, stale-while-revalidate, you basically can keep serving cached responses while also updating your data on the background. That means that the user will always have very fast results because they're basically just hitting the CDN cache, which is very close, and it basically behaves like a static page. However, A user visiting your page or making an API call that uses this header will also trigger an update so that the next user will have an even fresher content. So here's a small example. Imagine you have a page that's already cached and the user visits your page. That will be served whatever is in cache. And for that user, that's the end of it. But that visit will trigger the revalidation. And the CDN cache will invoke your serverless functions that will get data from a CMS or from any other systems, and then update the CDN cache. After that process takes place, the next user will actually get that new version. But he will also trigger a new revalidation so that the cache keeps fresh. This way, organic traffic basically keeps your cache fresh, and users basically don't have to wait for serverless functions or even whatever server you might have to finish fetching data and static content fast. A couple of downsides for stale-while-revalidate is that it doesn't have an initial cache. So if you're using a regular builds and building all your pages up front, those are already in the CDN, and the user will never have to wait for any function or anything. But in this case, you have to run it at least once to generate the page in the first place. That means that the first user ever after deployment to go to a particular page will have to wait a little bit more and actually wait for the serverless function to run because we don't really have anything cached yet. That's not a big issue. It's a very, very small number of users that will experience that. And the serverless function is pretty fast. It will be just a matter of, instead of less than a second, to wait a second. But it's still nice that the overwhelming majority of users will benefit for lightning fast page loads. The other potential problem is that pages with low traffic have the risk of becoming a little bit stale. So if no one visits your page for a long time and you're still serving the cached version, there's a chance that a page changed a little bit and that user will not get that. It will trigger a refresh for the next user, but if the next user also takes too long to visit your page, they will always be like one page behind, which is definitely not what we want. And that's why we need to make sure that we set the proper values in our headers to limit this behavior if that's an issue for you. For some use cases, some pages, that really doesn't matter much, because if a page is really doesn't have much traffic, there's a chance that there is no new content anyway. But that could not be the case for example, products that don't have a lot of visits. You may want to mark it down and you want that to be available as fast as possible. So we need to make sure that we don't serve too stale content, and we'll talk about that in a minute. So here's an example of how you're going to set that header. You should use this code on your get server side props or on your serverless functions. I'll talk a little bit about the two values that you can select. The first one is the S max age, and that behaves like regular cache. That means in this example that for 5 seconds, whatever request that happens will be served on the cache, but it will not trigger any update and nothing different will happen. It's as if you were using just a regular CDN cache. However, with stale-while-revalidate, in this case, 120 seconds, you're basically saying, okay, after 120 seconds, that my content is no longer fresh, I'm still willing to serve that content as long as I revalidate that content on the background and update my cache. So that means that during this window, requests will basically serve the cached version, but trigger an update. And when that update is ready, your cache is fresh again. So you basically come back to this initial scenario where you have 5 seconds where it doesn't trigger any update, your cache is fresh, and then it goes back to the stale-while-revalidate. And as long as you have traffic going on, That keeps happening. After 125 seconds, though, you won't serve anything from the cache anymore. You're basically saying, throw the cache away, make the user wait for my serverless invocation, because I don't want any request to have data that's 125 seconds old. If you need more details on stale-while-revalidate, you can visit this link that I have on your screen. It's a very good resource for diving a little deeper into how that works, but we don't really have a lot of time to dig deeper, so I'll move on. So because you set that header on each page and on each API that you want to cache, you can basically select different values for different pages. In our case, we identified three main scenarios. The first one is content. Content pages are any pages that are basically driven by the CMS, and content creators, they add content to the CMS, and then our page picks that up. Some examples are the homepage, which basically is a bunch of components that it can configure via the CMS, banners, promotions, carousels of products. Another good example are blog pages. These are basically just CMS-driven. Content creators write up some tests, put some images, and it's there. It's nothing that's actually done during build time. These types of pages can be cached aggressively because usually there's not much impact in having older content for these pages. If you have a blog page, it probably won't change a lot. So if you cache it a little bit more aggressively and it takes, instead of instant update, it takes a few minutes, it really doesn't impact a lot. So that's a business decision. You have to understand what actually matters or not in terms of stale content. But in our case, all these use cases were fine to cache a little bit more aggressively. So the numbers we chose were 120 seconds for the max age, which is basically regular cache, and 1 day for the limit for the stale-while-revalidate to actually give up on serving stale content. So 120 seconds, 2 minutes, was the time that the content creators were okay with waiting. So as soon as they publish something on the CMS, it can take up to 120 seconds to appear on the production website. And that was something they were comfortable with. We could have lowered this value to 1, for example. That would mean that a 1-second cache is basically not even a cache for delays purposes, and that would be very good for the content creators. However, it would put some unnecessary load on our serverless functions and our other external services. You probably are paying for serverless functions or have a limit on serverless functions, and you don't want to keep calling it every second if you have high traffic to rebuild a blog page that probably didn't change. On the other hand, you don't want your content creators waiting more than 2 minutes after they make a change to see the change appear. So that was a number that we were comfortable with for both the performance and the use case for the content creators. Another use case is product pages. Product data doesn't change a lot, but there are two main factors that are very volatile. The first one is price. In our specific case, prices don't change twice a day. Usually, it's not likely. They're not changing every day either, but there is some kind of volatility. Unlike the product description or images that almost never change, price can change on a daily basis theoretically, but the inventory is a key point. Inventory can change very, very fast. If you have a sale, if you have a price drop, it can change within seconds or minutes, and caching would make your users get the wrong information, and that's not good. So at first we thought we couldn't cache the product page, but there was so much data that was highly cacheable that we stopped and thought about what kinds of cache are we talking about? We're talking about caching the HTML file. That's basically only used for server, search engine optimization. And that doesn't happen every second or every minute, just a few times a day. So we don't care that our HTML could be 2 minutes late. That's not a big deal. However, we want the user to have the most recent data regardless. So the solution we came up with is that we basically keep using the same values as the content, but we make sure to refetch inventory data as soon as the page loads. As you can see here, the headers for the SSR, basically the get server-side props, they are basically the same as the content creation. 2 minutes, a regular cache, and then 1 day for stale-while-revalidate. That's fine for us. However, as soon as we load the page, we want to make sure that we get the right values. For that reason, we are not caching our API at all. We decided that this was our source of truth. Sorry, that was our source of truth, and we were not comfortable caching it in any case. So whenever the front end needs to know if is there inventory for this product, we hit our API, there's no cache, it's going to hit our systems. We wanted really to be 100% sure that that value was not out of date. However, we leveraged the application cache a little bit. So we have a 60-second cache on the React query library. That's our data fetching library. And that ensures that we're not making 2 requests because 2 components that are a little bit far apart need the same data between 60 seconds, or you change a page or you open your cart and then you get an inventory again. It's not really very likely that inventory is going to change that on a regular scenario. So 60 seconds was fine. We do have some safeguards, like making sure that as soon as you get some kind of error from your management system saying, oh, there is actually no inventory, you cannot add data card, that's an error. We clear this cache and make sure that the whole application understands that there's no more inventory, and then all the UI gets updated, and then it gets consistent with our cart system. The other scenario is sales. Sales is basically the same as products. It's the same page we're talking about, but sales and price drops can cause a lot of traffic, and user tolerance is really low. If you have a price drop for something that's really high in demand, people will open multiple tabs, they will keep refreshing, and they will be very annoyed to get the wrong information about availability. These things can disappear in a matter of minutes or seconds. So we really need to make sure that we provide the best experience possible to the user here. And one of the things that doesn't happen often on the regular scenario, but that can happen more if the user is always refreshing the page, for example, is a little page blink. If your HTML is actually a little bit out of sync with your actual API, what's going to happen is that it's going to show as if it had inventory, and then in 1 second it will blink into the sold out state, for example. That's really rare for regular scenarios because we're talking about inventory going from greater than 0 to 0, and it's really something that doesn't happen very often. But in the case of a price drop or a Black Friday sale, that can happen. And if the user is actively reloading the page and opening multiple tabs, that will happen. So we want to avoid that negative impact. The way we chose to fix this issue is basically we can configure the the header values via an environment variable. So whenever we have a price drop or whenever we have a big sale, we can just change the values for our SSR headers to ensure that we don't get for 2 minutes. In the case of sales, we've been using 10 seconds for max age because 2 minutes for a sale or for a price drop is an eternity, and we don't want users having the blinking problem appearing for 2 minutes or anything. And 10 seconds already is enough to alleviate the problems of loading the server or calling too many functions. It's already a sale, we already have high traffic, so we can't really put that to 1. That might be too much, but 10 seconds is workable. The other thing we do is to completely disable the application cache, the React query cache. We really, really don't want the user having any kind of discrepancies, and 60 seconds is a long time. Again, when you have a sale, when you are opening multiple tabs, when you're trying to add stuff to cart and add the product that you really, really want. So we just disable it. In our specific case, it doesn't generate a lot more calls, but if the user clicks around real fast to add to cart, then open the cart, there could be a few calls that could have been prevented, but it's better that the user have a great experience and does not have conflicting information where they can think they can buy something, but it's actually out of stock, which is really the worst thing that can happen when people are trying to buy a product during a sale. And that's basically it for our cache strategy. So stale-while-revalidate really brings the speed of static into dynamic context. You can use regular server-side rendering, but benefit from really, really fast responses. What you need to understand is when to trade off performance for correctness, because some pages can be out of sync for a little while, others not so much. You also need to remember that you can always refetch your data on your front end. And if you're really worried about the blinking effect that we mentioned, in your case, you might want to go for a loading spin instead of the actual value. There are many other ways to avoid the blinking effect, but usually you just have to remember if your data is critical, you probably should be refetching it on the client to make sure you have the most accurate data possible. And don't be afraid to cache. It's really, really powerful. We had so much positive feedback about this, about our pages and the speed of the new site. Just make sure that you keep the user experience consistent and that they won't be misled because you have something cached that is really not the reality anymore. Whenever you have those more impactful scenarios, you have to be a little bit creative and tweak your cache values so you ensure a great user experience. Thank you very much for your time. To continue this conversation, we'll be on the Discord channel, on the My Planet Discord channel. So we'll have a Q&A session there. If you have any questions, I will be there to answer them. Thank you very much.